Hello, today I'm going to show you how to convert RGB image to sepia image using concurrent programming in C language. Alright, as you can see, I have two header files. One of them is chapp.h and the second one is ppm.h. chapp.h has all the prototypes, functions, and definitions to help you process C program. The one I used was standard I/O wrapper, dynamic storage wrapper, dynamic storage iteration wrapper, and the thread control wrapper. The next one is the next one next to chapp. Okay, the one next to chapp.h is chapp.c. But this one, it has all the callings of the function. So the one I mainly used was here it is, Unix IO routine that I use for oh no. Don't. Okay, this actually the first thing I did was the first function calling is dynamic storage alteration function, which I use for this one. Oh, the only one, yes. The standard IO function would be fclose, fopen, fget, fgets, freads, and fwrites. And finally, the last one will be the thread control function, which I use for create and join. Alright, the second header file is the ppm.h file. This one, I'm calling out the ppm files. The ppm files stand for portable Patrick. Sorry. The ppm.h files stand for portable pixmap format. So basically, you read the pixels of the photos. Oh no. Here you can see right here. This is the image of the 9 group of dogs. So I use the data structure of colors, that's red, green, and blue, and data structure of widths and heights. Now it includes the ppm pixels pointer data as well. And here's the two prototypes functions. That would be read ppm and write ppm. Here you can see ppm info.c. This one includes ppm.h and chapp.h. So I called the function read ppm, which is used to call for any sorts of image files like this. And also did some error. There's also some error messages like if this cannot open, that means the second files won't open either, and it won't change the colors. If P or 6 are not in the format of the image, it'll be invalid. What I mean is, here, oh my goodness. Sorry, give me a second. Sorry, it's supposed to download it. Okay. It's not working well. Alright. See right here, P6, that's the format of the image. So without it, it won't work. Right? And this one's for automated memory. So basically, if the image don't have enough memories or it's bigger, it'll be unable to automate the memories. Next is the sizes. If the size is big, it won't be opened, and the program won't be complete. Then finally, the 8-bit components. Like if you change right here, it will not have 8-bit components. Next, all right. Yeah, same thing right here about the alternate memory and read pixels. It'll be error for not having enough pixels. All right. The last function will be the write ppn. This one's for writing the second file. And again, if the first file will be open, then the second file won't be open. And I'm not sure I will have these printed out, but at least it will work. Next is sepia.c. For this one, I'm doing a conversion of RGB to sepia. Here I have the function for it, and I have 3 arguments. It'll be ppn pixel to data pointer, IET width, IET height, and I have x and y for it. So I have the whole for loop right here, and this is the color components for each data. Like data equals, sorry, like red equals data array of y times width plus x dot red. And green would be data array of y times width plus x dot green. And for blue would be data array of y times width plus x dot blue. Here's a formula for RGB to sepia. Like this could be sepia red, this one could be sepia green, and this one could be sepia blue. There are many formula for it. Like you could change RGB to gray or any form of colors. Just you need to understand the pixel colors. And here we have the if statement for changing the colors. Like if component color is bigger than sepia red, then it will stay red. Else it will change colors. If the color component of if the color component is bigger than sepia blue, it will stay blue. Else, sorry, it's supposed to be green. So, let me rephrase it. So, if the color component is bigger than idiot green, then that means it will stay green. Else, it will be idiot green. Sorry. For blue, if the color component is bigger than blue, it will stay blue. Else, it will be sepia blue. Alright. Next is new photo.c. This is the final foundation of the project that I'm doing. Alright, here I have the 4 threads for safety of open the files, and I have 2 arguments of main. So I'm using ppn image to do pointer image. Here I'm calling the image name, which is 9dogs.ppm. This is before calling 2 threads, like, yes, calling 2 image shy. This is for the original image. This one's for forming the sepia photo. This one's for identifying the threads. Yes. This one's starting the new threads of 1 and 2 to the calling process. This one's waiting to terminate, like basically waiting to be open. And once they're open, you'll see the second one called 9dogs ppm, and it'll print new photo complete. And in the threads, you can see that it still have the ppm image equals to vargp, yes. And then this is where you call the sepia function, because we need to process the colors, yes. And then it will turn to null. So let's test it out. Give me a little warning, but that's fine. New picture. New photo, sorry. Alright. And it should be open. Give me a second. Here it is. I can't open the system, but you have to right click download. And you should have a file user app. And see? Here's the sepia color of the photo. Now let's see what happened if let's see what happened if I did subtraction. Control safe. And let's see what happens. Oh no, that's not good. See? It only did half a sepia and half a full color. That's not what we wanted. We wanted full sepia. So you gotta be careful of how you write it, how you write the code for changing the colors. Because if you don't proceed that way, you're gonna end up the same mess that I caused, which is you want to see this, but you don't want to see that. You just want a full one, which is this one. So yeah, I hope you enjoyed these videos. I know that I would.